Hello, dear students. You're welcome to RK Institute. I am Dr. RK Seni, and today I am going to discuss some more questions regarding to biomolecule as well as coordination compounds. Dear student, as you know, I keep posting some important questions for your IIT-JEE, NEET, JRF, CSIR, UGC, and IAS conducted by UPSC. I think these questions are help to you to improve your chemistry as well as to understand some basic concept. And these questions are help your in different examinations. If you think it is the truth, then I want to you to subscribe and like my channel and share these questions of your known persons. Question number first. Today we discuss some important questions regarding to biomolecules and coordination chemistry. Question first. This question taken from biomolecule and this question asked in IIT-JEE in 2012 years. Question. The substituent R1 and R2. Substituent R1 and R2 in given peptide chain. Okay? Listed below how many these peptides are positively charged at pH 7. First of all, understand the meaning of the question. We know that amino acids make peptide or polypeptide by the linkage of peptide bond. First, amino acids are exist in form of deuterion because acidic and basic both groups present in the amino acid at their neutral point. Deuterion carry both charges, positive and negative, at their neutral point. Neutral point is also known as isoelectric point of the amino acid. Neutral point is also known as isoelectric point. Isoelectric point of the amino acid. Or we can say at this pH, amino acid carries equal charge of positive as well as negative. Or we can say this amino acid does not net movement toward the anode as well as cathode at neutral point or their isoelectric point. First, now if solution, this is the deuterion of amino acid. Now, in case of acidic solution, first, in case of acidic solution, this deuterion exists in form of cation. In acidic solution, this deuterion exists in form of cation because H ion combined with acetate ion or we can say carboxylate ion, therefore it carry positive ion. In case of basic medium, H plus ion donated by the ammonium ion and the amino acid exists in form of anion. The amino acid exists in form of anion in basic medium. The given question is asked the amino acid exists in form of cation. It means a cation form exists in form of acidic medium. It means pH 7. ध्यान से सोचिए, it means pH 7 is an acidic. pH 7 is an acidic for this amino acid. Or we can say the amino acid which carry pH 7, then the solution of pH 7 become acidic for these amino acids. Therefore, we identify R1 and R2 by which given peptide chain become basic. Or we can say by which peptide chain carry has pH more than 7. First, we think about this question. In pH 7, the amino acid exists in form of cation. This is possible when pH 7 is an acidic for given peptide chain. It means the peptide chain become basic. Then basic groups attach R1, R2. For example, this group is basic. This group is basic because NH2 group. This group is also basic. Question 9, question 8. This group is also basic because the alcohol are acidic. This group is not possible because amide are amphoteric and HD acidic. मतलब आपको क्या करना है, बेसिक ग्रुप्स अटैच करने हैं। तो वी आइडेंटिफाई बेसिक ग्रुप्स 8 9 both are basic question. Option 6 both are basic possible question. Option 5 not possible because amide nearly amphoteric question. 4 option is also basic because amide amphoteric, but this group is basic. So it 9 8 6 and 4. And also consider another group. This is the acidic, neutral. Therefore, R1, R2 may be NH2 or basic group. I can say basic there. Therefore, in given polypeptide, yeah, 9 peptides, only 4 groups R1 and R2 present in this compound. Then this compound show basic nature, and pH 7. And in pH 7 is an acidic for this, and in which the deuterion exists in form of cation. Answer 4. Question number second. Question second. This question: which of the following structure correct structure of alpha anomer of maltose? First, maltose C12 H22O11. Then it gives two molecules of alpha D plus glucose on their hydrolysis. Alpha D plus glucose on their hydrolysis. Glucose, two molecules, and hence it is disaccharide, O6, alpha D glucose. First, we write their open chain structure. It is the structure of D glucose. First, we write open chain structure of glucose. And the anomeric carbon is first because after formation of acetyl ring, then it become chiral. H and at carbon 5, alcohol of at carbon 5 combined with carbonyl group and make acetyl aldehyde and alcohol, make acetyl ring, particularly hemiacetyl ring, because one alcohol molecule reacts this. Therefore, when OH group present in right hand side, then this anomer is known as alpha. And when OH group present in left hand side to the new generate chiral center, then it is known as beta. Therefore, anomeric carbon is two types, namely alpha and beta. And hence this structure is known as alpha D plus glucose. When we write their Haworth projection formula or pyrene type structure, then the right hand side group represent downward. For example, at carbon first, OH downward, H upward. Carbon second, OH downward, H upward. Carbon third, H downward, OH upward. Carbon 4, OH downward, H upward. And carbon 5, H inside the ring, and CH2H outside the ring, because hydrogen bonding also takes place. And this is the structure of anomeric form, particularly alpha glucose. Alpha D glucose is alpha and is pyranose type structure. And in case of glucose, two molecules of glucose, they combine, make a glycosidic linkage at carbon first and carbon 4, carbon 3 and carbon 4, then the formation of glucose. Therefore, the glycosidic linkage is formed between carbon first of one molecule and carbon fourth of second molecule. For example, this is the one molecule of alpha D glucose, particularly alpha form. OH, H, OH, H, carbon third, H, OH, carbon 4, OH, H, H, और इस पे कार्बन H और ये CH2OH. This carbon is first, and another molecule of glucose, alpha D glucose, OH, H, ये same arrangement, and this is OH and H. And the glycosidic linkage is found between first carbon of one molecule and fourth carbon of another molecule. And after removal of water from two molecules, the glycosidic linkage is found between first and fourth. And this glycosidic linkage represents as this type. Therefore, it is the molecule of maltose. And hence structure D option is correct. Check, please check the all options. And as anomer of maltose alpha is this answer. Question number 3. This question is also asked in JEE Advanced. Total number of natural occurring amino acid. Dear students, it is very important for you if you learn all 20 essential 20 amino acid which make protein or polypeptide chain. Because you learn structure of all, then this question you can be done. For example, this question on hydrolysis, how many natural occurring? First, peptide chain, polypeptide chain. Polypeptide chain gives different type of amino acid on their hydrolysis. In acidic medium, hydrolysis, NH group change into NH2 and CO group change into acid. So on their hydrolysis, we obtained separate molecule of amino acid, particularly NH2 and COH group. First, when this peptide chain is hydrolysis, then this H and OH group. And this peptide chain is hydrolysis, then this group contain OH and H. And hence, we consider this amino acid NH2, CH2, and COH. It means it is glycine. Amino acid is glycine. And it is natural occurring amino acid. 20 amino acids are natural occurring amino acid, glycine. This part is also hydrolyzed. This part is also hydrolyzed. Therefore, this group is also glycine. So this ring consists 2 molecules of glycine. Now, on the hydrolysis, we obtained. Now, hydrolysis in further, then we obtained following amino acids. Observe the structure of amino acid. COOH, देखिए, acidic group contains CH, then CH2, and a cyclopropyl hydrocarbon part, and also contain NH2. It is not natural occurring, it is amino acid. But in this question, you identify natural occurring amino acid. Therefore, it is not natural occurring amino acids. In another peptide chain on hydrolysis gives COOH, C acidic group plus CH and a tertiary butyl group and NH2. Such amino acids are also not natural occurring. Therefore, it is not your answer. Same question second, same this. And the in last, when polypeptide chain on hydrolysis, this gives COOH, CH, CH2, a cyclopropyl ring, NH. This bond is also dissociated during the hydrolysis. NH and COH. NH and this part contains CH2, COOH. It is not natural occurring amino acid. And but on their hydrolysis, it is glycine, further glycine. Therefore, the natural occurring amino acid is only one, namely glycine. Dear students, 20 amino acids are important for your examination. So I suggest you learn all 20 amino acids, their single letter code, as well as their structure. For example, the amino acid, total natural amino acids which make protein are L amino acid. It means NH2 group present at left hand side to the natural occurring amino acid. This is the L amino acid. When G is following group, then they are the structure of amino acid. When G is H, then this amino acid is known as glycine. This amino acid is known as glycine. the single letter code is G. When G equals to methyl, then this amino acid is known as alanine. Alanine. Single letter code is A. When this G is isopropyl, then it is known as valine. Single letter code is B. Then this G is CH2 and one phenyl group. At the G, one phenyl group. Then it is known as phenylalanine. Single letter code is F. G. When this G is isobutyl, then G is isobutyl. Then this amino acid is known as leucine. Single letter code is L. When this alkyl group is secondary butyl, or this group G is secondary butyl, then it is known as isoleucine. Single letter code is I, capital I. Dear student, therefore 6 amino acids H, CH3, this and this are, I think, neutral amino acid, because number of NH2 group and number of CH2 group are equal, and their pH is nearly 6. These are important amino acids or neutral amino acid in which valine, phenyl, alanine, FCD से denote किया, leucine and isoleucine. They are essential amino acids. You know that total 10 amino acids are essential amino acids, because these amino acids are not synthesized in our body, or we can say these amino acids take by the diet, from diet in our body, and hence particularly valine, leucine, isoleucine and phenylalanine are essential amino acid among neutral amino acid. So these are the 6 amino acid. Then you learn 2 acidic amino acid. Then 2 amino acid are acidic, namely aspartic acid and glutamic acid. And following groups present at the G in aspartic acid and in glutamic acid. Following groups present in amino acid at the place of G. CH2 COOH. If G is CH2 COH, then it is known as aspartic acid. The single letter code is D. When G is CH3 CH2 and another CH2, the amino acid is known as glutamine. Glutamic acid. The amino acid is known as glutamic acid. Single letter code is N. These amino acids are acidic and their pH nearly 3. Because they contain more number of CH group than NH2 group. These are known as acidic amino acids, and 2 amino acids are their amides, namely aspartic acid. This functional group change into NH2. Then this amide group and is known as asparagine. Glutamine. Then when amide group in glutamic acid change into glutamine, asparagine represented by R and glutamine glutamic acid, and their amide is glutamine, denoted by Q. Asparagine is denoted by N, and glutamine is denoted by Q. And their pH is also nearly 6, nearly 5.6, or slightly acidic. Then 8 amino acids. Now 2 amino acids which contain sulfur in their structure. Important 2 amino acids, namely cysteine. It contains thioalcohol group SH at the place of G. Cysteine and methionine. It contains thioether group. In which methionine is also essential amino acid. 2 amino acid contains sulfur in their structure. And learn 4 amino acid which contain alcohol or phenolic group. And their single letter code cysteine is C and methionine is M. 2 amino acids. 3 amino acids contain alcohol in their structure. For example, serine. For example, amino acid serine, denoted by S. Next, amino acid threonine. It is also contain alcohol. This group present at the G is known as threonine. Denoted by T. They are also acidic and their pH is nearly 6, something 5.7, etc. Nearly 6 or 5.6. Next, third is triosine. It contains phenolic group. Tyrosine contain phenyl group. And the single letter code is tyrosine is Y. These amino acids are also slightly acidic. Their pH is nearly 5.6. These 3 amino acids contain alcohol or phenolic group. Now, some amino acids contain more number of NH2 groups. For example, lysine. For example, amino acid lysine. Arginine, histidine, proline, etc. G. Arginine, NH2 and CH2, 4 times CH2. This is known as lysine. It is basic amino acid. Lysine. It is basic amino acid denoted by K, and their pH is nearly 10, 9.8. Now, highest basic amino acid is NH2, C, double bond NH, then NH2, CH2, CH2. Arginine is most basic amino acid among all known. G is this, because this part of the amino acid show resonance by their protonation, and as it is most basic, nearly 11. Its pH is nearly 11, 10.8 pH. Most basic amino acid. Arginine, denoted by R. Next, histidine and lysine, basic also. Proline amino acid. See the structure of proline. It is heterocyclic amino acid containing a ring. It is proline. Proline amino acid. Denoted by F. Proline amino acid, no. Denoted by P. Sorry. Denoted by single letter code is P. Proline. Histidine. Another amino acid is histidine. Histidine is also heterocyclic compound in which a ring nearly pyrrole type. NH, resonance is there, and this free valency attached to the carbon chiral center. It is the known as histidine, denoted by single letter code H. It is also slightly acidic, pH nearly 6, histidine. And another amino acid is tryptophan. Another amino acid is tryptophan. It is heterocyclic compound also and consists 6-membered ring and 5-membered ring. 5-membered ring is like as pyrrole, and the adjacent valency contains CH2. It is known as proline, and their single word is W, and their single letter code is W. Therefore, these amino acids are important, and 10 amino acids are essential. 3 amino acids like as tryptophan, arginine, lysine are also, and histidine, lysine, histidine, proline, and arginine are essential amino acids. 4 nitrogenous amino acids, 1 is threonine, is essential, methionine, and 6 these and histidine are important amino acids. Next question. This question asked in JEE examination 23, and following tetrapeptide represent as this. And this question is mainly asked for your learning capacity. For example, single letter code. You identify single letter code. For example, when this polypeptide become hydrolyzed, then phenylalanine, amino acid phenylalanine, denoted by F. During the second hydrolysis, then this amino acid contain isobutyl group, and this is known as leucine, denoted by L. First by phenylalanine, denoted by F. Second amino acid is contain isobutyl group and is known as leucine. And third amino acid on their hydrolysis, this amino acid is aspartic acid. Notice this amino acid is aspartic acid, contains COH and this, and aspartic acid denoted by T. And in last, the amino acid is triosine. Denoted by Y. Therefore, your answer is second. Question number next. This question is asked from coordination chemistry in CSIR UGC NET, conducted by CSIR and UGC NET examination in last year. Given complexes and list second. Match the complexes. For example, in compound first, the oxidation state cobalt is +2, and we know that cobalt +2 contains 7 electrons at barycenter or d orbital. This complex is octadal. Therefore, 2 energy levels in octadal complexes, namely T2G and EG. The ligand is weak ligand because the oxidation state cobalt is +2. Therefore, these electrons are contained 5 electrons in T2G and 2 electrons in EG. Now, magnetic moment is higher than spin magnetic moment, and so Joule-Thomson distortion. First, this complex, so weak Joule-Thomson distortion because the d orbitals are unsymmetrical filled in particularly T2G. When d orbitals are unsymmetrical filled in EG, then Joule-Thomson distortion is very powerful, not weak when strong. This is the weak Joule-Thomson effect because unsymmetrical arrangement of T2G orbital. However, EG orbital are regularly filled or symmetrically filled. Weak Joule-Thomson effect, and their spin magnetic moment, and their magnetic moment is greater than spin. Spin magnetic moment contain only 3 unpaired electrons. Therefore, by experiment, spin magnetic moment is nearly 3.844 magneton. But their magnetic moment is greater than this value because orbital spin magnetic moment is also involved. In question number second, the oxidation state of chromium is +3. +3. Oxidation state of chromium is +3. And in +3, octahedral complex are stable because T2G orbital have half-filled electronic configuration in their +3 and they are stable and symmetrically filled and does not show Joule-Thomson distortion, and only spin magnetic moment is the magnetic moment of species because no effect of ligand in case of chromium +3 and are stable due to T2G orbital are half-filled according to Hund's rule. Question next. NiCl2 and P triphenylphosphine. Triphenylphosphine is bulky ligand. Phenylphosphine, it is the phosphine. And in case of triphenylphosphine, 3 hydrogen replaced by phenyl. Therefore, it is very bulky ligand. And Cl is weak ligand. Therefore, it is the tetrahedral complex. In nickel +2, tetrahedral complex. In tetrahedral complex, 2 orbital, E orbitals are downward and T2 orbital are upward. D8 electrons are filled according to Hund's rule also, because all tetrahedral complexes are the high spin, because the pairing energy is always greater than the delta T. Therefore, electron 1, 1, then 3, 4, and then pairing. And hence it contains 2 unpaired electrons, and the molecule is formed by the combination of S and P. Therefore, tetrahedral and paramagnetic and tetrahedral. In last D option, the oxidation state of palladium is also 0. And in 0 oxidation state, palladium, important, the oxidation state of palladium is 0 because triphenylphosphine is neutral ligand, coordination number 4. And in palladium, their 0 oxidation state, the ground state electronic configuration is 4d10, 5s0, and 5p0. Therefore, this complex is also tetrahedral but diamagnetic in nature and use their outermost or d orbital. Diamagnetic and tetrahedral. Palladium in 0 oxidation state, electronic configuration is 4d10, 5s0. Important. Okay, these are the questions from coordination and biomolecule, etc. Okay, bye.